today's session is on use of network survey vehicle, which is very, very important because we are interested how to leverage the technology for betterment and enforcement of various contractual provisions, especially the O&M provisions को कैसे leverage करते हुए टेक्नोलॉजी को करना है, उसकी कड़ी में ये नेटवर्क सर्वे व्हीकल बहुत इंपॉर्टेंट है। अभी आज दो पार्ट रहेगा। एक पार्ट रहेगा नेटवर्क सर्वे व्हीकल के बारे में बताएंगे डॉक्टर प्रदीप कुमार, बहुत ही एमिनेंट साइंटिस्ट है। ही इज चीफ साइंटिस्ट एंड प्रोफेसर इन CRRI न्यू दिल्ली। ही इज ए PhD फ्रॉम IIT रुड़की एंड वेरी रिनोन्ड एक्सपर्ट इन द फील्ड ऑफ NSB एंड FWD। उन्होंने 30 साल से काम कर रहे हैं एंड ही इज आल्सो वन ऑफ द फर्स्ट NSB इन इंडिया जिसके ही वाज वन ऑफ द की इम्प्लीमेंटर्स है। तो उन्होंने उनका IRC एंड अदर चीज में काफी कंट्रीब्यूशंस है। वी आर लकी टू हैव हिम टुडे एंड वो आपको नेटवर्क सर्वे व्हीकल का निटिग्रिटीज एंड डिटेल्स एंड हाउ टू यूज इट ही विल एक्सप्लेन एवरीथिंग ऑन दैट फर्स्ट प्रेजेंटेशन में। उसके बाद NSB टेक्नोलॉजी को लिवरेज करते हुए हम लोग O&M में जो एक मॉड्यूल बनाए है प्रायोरिटी मेंटेनेंस मॉड्यूल, जो हमारा पार्ट ऑफ द डाटा लेक है, उसका यूसेज अभी तक काफी कम है। उसका यूसेज को कैसे बढ़ाना है। दूसरा, हम लोग हाईवे ऑपरेशन डिवीजन में वी आर ट्राइंग टू गो फॉर ए अपग्रेडेड वर्जन ऑफ NSB, जहां पे 3D टेक्नोलॉजी के साथ ऑलरेडी हमने अवार्ड कर चुके हैं कई जगह पे। वहां पे भी 3D टेक्नोलॉजी में हम उसका मेंटेनेंस का जो मॉड्यूल्स के ऊपर में जो NSB डाटा है उसको कैसे करेंगे, क्योंकि आज का डेट में NSB डाटा का एक्विजिशन और डाटा को ट्रांसफरिंग इनटू नॉलेज बहुत ज़्यादा गैप है, क्योंकि हम डिपेंडेंट है अथॉरिटी इंजीनियर का, इंडिपेंडेंट इंजीनियर का, या जो भी हमारा फील्ड स्टाफ का है, जिनके पास इतना वेरिबिटल नहीं है उसको डिसिफर करने का। उसमें हम अभी एक टाइम बाउंड प्रोसेस करने का जा रहे हैं, जिसके बारे में हम इसके बाद भी एक बताएंगे। देन उसके बाद एक क्वेश्चन आंसर सेशन भी रहेगा। आपका कोई भी NSB रिलेटेड डिटेल्स आएगा तो हम करेंगे। सो इट्स माय प्लेजर टू हैंड ओवर टू डॉक्टर प्रदीप कुमार। May kindly start his address, please. Thank you.
Namaskar, thank you, Mr. Padiji, for a nice introduction. And Chairman NHAI, Shri Santosh Kumar Yadav ji, other board members, senior officials from the NHAI office and from the field, and participants, a very good morning to all of you. एक्चुअली सबसे पहले मैं बधाई देना चाहूँगा चेयरमैन सर को कि जो उन्होंने बताया कि एक बहुत अच्छी शुरुआत NHAI में की गई नॉलेज डिसिमिनेशन के लिए। तो रियली में आप सब लोग बहुत ही बधाई के पात्र हैं इसके लिए, और ये बहुत ही अच्छा इनिशिएटिव है। एंड आई एम ट्रूली ऑनर्ड एंड वुड लाइक टू एक्सटेंड माय सिंसियर ग्रेटिट्यूड टू NHAI for this opportunity to share my experience, as I am working actually at CRRI from the last 28 years in the field of road asset management, and with the help of Ministry of Road Transport and Highways in the year 2006 we bring first network survey vehicle system in India. So I will share my experience on data collection and analysis using network survey vehicle system in my presentation. So give me a few seconds to share my presentation. I hope my presentation is visible to all of you.
Yes, sir. Yes, sir. It's visible.
So this is actually the presentation or the discussion, I will call it. This is on network survey vehicle system. Just a minute, moving. Yeah. So what is basically a network survey vehicle system? This is network survey vehicle system. Actually, in my opinion, it is a commercial name given to a automated road service system. Okay, so it is a very specialized infrastructure management tool which comprises of the various equipment or sensors and one data acquisition system fitted in a survey vehicle. So in my opinion, it is a automated road service system, and these vehicles systematically collect data on road inventory and condition at highway speeds. So here this is important that we can collect the data at highway speeds, that in a minimum time we can collect the complete data related to road inventory and the pavement condition with the traffic itself. Okay, and this data, how this data is going to be useful for us, it is useful for us to make the maintenance planning, to maintain our road assets, to do some infrastructure planning related to, we can do some strategic level planning also using the data we collect using these modern data collection techniques. And ultimately, we are contributing for the safety and efficiency of the transportation networks. So this is the ultimate goal. We want we want to use this data, and because our ambition is very high, and we are going to take the management level, planning level, infrastructure management level decisions based on this data. So we want to ensure that the data we are collecting must be very accurate and reliable also. Right. Yeah. What are the applications area of this data? Let us just, I am just giving you 3-4 slides on the application part, and then we'll discuss the real what is network survey vehicle now and how we should use it properly. The application of network survey vehicle data, we are using for the payment management part. Actually, the way payment management part means, we are assessing the payment condition. Just a minute. Just a minute. Yeah. So we are assessing the payment condition, and we are collecting the distress data. We are collecting the riding quality data, and to prioritize the maintenance activities and rehabilitation efforts to ensure safer and smoother roads. So this is the one goal which we call it as the payment management system. Sometimes we call it as a payment maintenance management system also. And if I go with the asset management part means we using the network survey vehicle, we are collecting the condition of the road assets. Okay. And then we are taking the appropriate maintenance measures, and we are trying to optimize the maintenance schedules and the budgets. So this is the another goal with the use of network survey vehicle data we are collecting. And the third one is the infrastructure planning. Okay. So infrastructure planning, if you want to do, we are collecting the data for infrastructure planning, design, and construction projects, including road widening, realignment, and rehabilitation initiatives. So along with the network survey vehicle data, we need to know the traffic details, we need to know the axle load pattern, we need to know the growth pattern of the road network. All this information collectively we are using to do the infrastructure planning. And safety improvement is another very important aspect here. So identifying safety hazards such as texture, because in network survey vehicle, we are collecting the pavement surface texture data also. So pavement surface texture data is actually, it is linked with the skid resistance properties of the pavement, and we have now high speed road corridors. So this information is very important, especially in rainy seasons when some vehicle is applying the brakes. Then this texture information is going to play a very big role related to safety. Potholes, we all know they are the safety hazards, and we don't want them on our highways. And inadequate signages to implement corrective measures and reduce the risk of accidents. So all these things actually we are collecting with the network survey vehicle technology. The laser sensors are collecting the texture data. Some laser sensors and the high resolution cameras are collecting the pothole information, and we are collecting the using the right of way cameras to collect the signage information and the median opening points also. Somewhere we feel that the location of the median openings are not proper. All this information we are collecting so that we can take the appropriate safety measures. And environmental monitoring is something new which I am adding for the today presentation, because the chairman NHAI is also present. We were having one discussion with a very eminent scientist in USA. He educated us. He told us actually, why not you are collecting the the pollution related parameters along with the network survey vehicle. You are doing the very good work with, you are collecting so much parameters related to the road assets and the payment condition. Why not you are collecting the environmental data also? So his point was very valid. So if you are monitoring the environmental parameters such as air quality, noise levels, and vegetation enforcement along road corridors, so we can support the pollution control and habitation preservation efforts also. So this is a new thing. So we can ask the NSV OEMs to put to some more sensors on network survey vehicles so that we can collect the environmental related data in future. This is some new dimension for the work we are doing. Yeah. So this slide actually when I just we see the road safety related issues, which is very important nowadays on our Indian roads. So we see lot of parameters we are collecting using the network survey vehicle system. Okay, so we can not only, but right now what we are doing, we are just using the network survey vehicle data for the road maintenance, okay, planning purpose, but not actually for the road safety audited or audit purposes, but we can use this technology for the road safety audit also. Like IRAP is one initiative where you can utilize this data, like friction data indirectly you can get using network survey vehicle in the terms of the macro texture depth. We can get the information related to the cross fall, hilliness, that is in terms of rise and fall data, age deformation, that is in terms of the pavement surface distresses. We are collecting the information, longitudinal unevenness we are collecting, that is the riding quality, that is the longitudinal profile of the road, curvature, that is the horizontal curvature. We can ensure that the curvature is adequate. We are collecting using network survey vehicle the rut depth information through the transverse profile to know the maximum point of depressions along the wheel path. And similarly, we are getting the crack information, we are getting the pothole information, macro texture information. So all this data, actually it is very useful, it will be very accurate, and we can put all this information to the available models related to the road safety. Okay, so this is one aspect related to the usefulness of the network survey vehicle data, which is very important. This is actually my I always call that the what is the mantra of the maintenance management. The mantra of the maintenance management is the pay now or pay more later. Okay, that means we want to say, because we have the various stages of the road maintenance. The first stage is the road routine maintenance. Second stage we call it as the preventive maintenance. Then we call it as the periodic maintenance. Then we call minor rehabilitation, major rehabilitation, and reconstruction. So the ones we just construct the road, the first graph you are seeing here, if you are not doing anything after constructing a road, because depending upon the traffic loading and environmental conditions, from the day one your road will start deteriorating. Okay, and this is the deterioration pattern. Okay, if you are not doing any routine maintenance or preventive maintenance or the appropriate maintenance, then what will happen? This you can see here with the demonstration. The road will behave like this, and at a later stage, you have to put more money to restore it. Okay. Similarly, the second graph you can see the various stages of the pavement maintenance. And here, if you are doing the maintenance at the right time, preventive maintenance, if you are doing, and after that, let us assume that you are not doing, even then you are having some benefit. That means the preventive maintenance or routine maintenance or the appropriate maintenance plays a very crucial role, not only in terms of the money, but in that way you can increase the life of the payment also. So, so many times in my presentations, I always say the maintenance word shall be replaced with the timely maintenance. Okay, so maintenance is not only important, but the timely maintenance is more important. So this is the all these we can just ensure the timely maintenance with the help of the data which we are collecting using network survey vehicle system. So this slide actually I have, as per my experience, this is my, you can say this is my copyright slide, which I call the payment maintenance management system has the three basic components. One is the data collection is the first need. If you want to do some payment maintenance management system using modern data collection techniques, where network survey vehicle is one. And then we put all this information to a road information system, which is the web GIS based system, which we have at National Highway Authority of India also. And after once our road information system is ready with the inputs from network survey vehicle, falling weight deflectometer, automatic vehicle counter come classifier, or some Excel load data, or some ground penetrating radar data and history data, all this information is ready. We can link this system to the management tool for performing the life cycle costing for selection of cost-effective maintenance and rehabilitation strategies. That means we want to actually optimize the economic benefits so that we can reduce the maintenance cost or minimize the maintenance cost and minimize the road user cost. So this is the ultimate goal. But what I am seeing right now, people are collecting the data, but they are putting this data to the road information system. But the whole information, the connectivity between the road information system to the management tool, so that we can optimize the fund, it is missing at this stage because lack of training or some other reasons. In this presentation today, I am going to focus. Just a minute. Yeah, so I am going to focus only the modern data collection part, and specifically on the network survey vehicle. This slide actually it has a complete 15 days course at CRI. So today only I am just touching only one part, the network survey vehicle system, which I am going to give you insight. Yeah, so network survey vehicle system. So this is the actually topic of the, with this background I start. Actually these some I am getting some messages, black messages here, and because of that I am getting some difficulty in for the next slide. Mm, yeah, yes. Network survey vehicle system, if you see the two pictures in this slide. First picture, actually this is the first network survey vehicle system which we bring in India with the help of Ministry of Road Transport and Highways. And in the year 2006, actually, Ministry has taken initiative to develop first GIS-based National Highway Information System, and that work was awarded to CRI. And using this technology, which we bring from Australia at that time, we could survey 40,000 kilometers of national highways covering all states of the country, and then a very beautiful web GIS-based national highway system was delivered to Ministry of Road Transport and Highways in the year 2010. And then second system we purchased in year 2010. This system we used for another study for golden quadrilateral road network. That is, the aim was to develop a management system for high-speed road corridors at that time with the help of the CSIR funding. So if we see broadly, the all network survey vehicle system have capacity to survey at a speed of 100 km per hour. That means from the minimum 20 km per hour speed, most of the time, actually, I will also tell you why the minimum speed of 20 km per hour is required. But maximum we can go up to 100 km per hour if your traffic conditions permit you. Okay. Then longitudinal profiling we are doing with the help of the laser profilometers in the front of the survey vehicle, so that we can get the riding quality data. We are getting the transverse profiling data, so that we can get the rut depth information, which is present on the wheel path uh, um, of the roads, and we are getting the texture information in terms of the mean profile depth, so that we can have some idea whether adequate ski distance is present on the road surface or not, so that we can ensure the safe movement of the traffic, especially in rainy season on high speed road corridors. Okay. And we are collecting the geometry data, which is more uh, relevant to the safety aspects related to the cross slope, gradient, horizontal curvature. Along with, we are doing the center line mapping of the, that it means we are creating a digital map of the road network using the GPS coordinates, longitude, latitude, and altitude. We are collecting the another important information, that is the pavement surface defects. We technically we call them the distresses present, like how much area is cracked, how what are the number of potholes, what are their sizes, what are the raveling present, or other type of distresses. So we are collecting the images, and we are getting the right of way videos and images, so that we can decode the various road assets. We can see their position, their location, and their condition also. So all these things we are recording using network survey vehicle system, and all data we are collecting in real time mode simultaneously in the computer device within the survey vehicle. And finally, we are importing this information to some specialized softwares for further data analysis as per the desired intervals, and we are generating the reports. So this is actually what I am explaining you about the network survey vehicle system. It is basically up to development of the road information system level, okay, itself. Yeah. So this is, if broadly, if you see, this is our network survey vehicle which we are using. So more all network survey vehicle which are present look like the screen you are showing here. In the front of this network survey vehicle, you can see one laser profilometer is there. Okay, so this is a state-of-art system, I must say. This laser profilometer basically it has two laser sensors on the either end of this profilometer, so that using these two laser sensors, we are generating the longitudinal profile of the road along the wheel path. So in that way, when we are moving this survey vehicle in a lane on our national highway, we are getting the longitudinal profile of left wheel path and right wheel path. Both wheel path longitudinal profile we are getting, and then we are using the software, specialized software, to analyze this longitudinal profile of both the wheel paths to get the international roughness index, which we call the IR value in meter per kilometer. So this is how this technology works, and the minimum speed prescribed for collection of this information is 20 km per hour. Because if you are moving below 20 km per hour, the accelerometer present on the top of the laser sensor doesn't work because of the less vibrations, and your results are not reliable. So the most recommended speed for laser profilometers is more than 20 km per hour and up, and you can go up to 100 km per hour depending upon the traffic conditions. In that way, using this laser profilometer, you are getting the two profiles in a one lane, left wheel path profile and the right wheel path profile, and finally you are getting the left wheel IRI and the right wheel IR. Also, using the same laser profilometer, you are collecting the texture information along the wheel path. Okay, so these lasers present here, they are collecting the texture information also in terms of the mean profile depth. So this is how this laser profilometer is useful to collect the information related to the riding quality and the texture information. In the back side of this these survey vehicles, you will see some kind of laser sensors. Here you can see the combination of two laser sensors so that we can generate the transverse profile. So by using the transverse profile, again, we are getting the two values. One is the left rut depth value and the second one is the right rut depth values. And inside this survey vehicle, we are having a combination of the gyroscopes and you can say the accelerometers, so that you are recording simultaneously the geometry information. What is the horizontal curvature? What is the vertical curvature? What is the gradient? What is the crosswalk? So all this information you are collecting. And also in the back side of the survey vehicles, you have some laser sensors, you have some cameras to collect the pavement surface images. Okay, so that I will just tell you the difference between the 2D system and the 3D system. Some 2D systems are having only cameras, but 3D systems are fitted with some laser sensors so that you can get the depth information also. And on the top of each network survey vehicle system, you are having one antenna, GPS antenna, so that you are doing the you are collecting the longitude, latitude, and altitude information for the mapping purpose. And in the front also you have combination of cameras. Like in this survey vehicle, we have one camera, look like CCTV camera normal, but it is a very high resolution colored camera, and all images or video you are the images or the information you are capturing with this eye, it is measurable. That means at the time of processing, whatever you are seeing on your screen, it is measurable. You want to measure something, what is the carriage width, what is my shoulder width, what is the other thing you are seeing. If you want to measure it accurately, it is accurately measurable. So these are some features of this network survey vehicle. And now again, I will go on more details, give you some idea and some precautions also while collecting these things. So longitudinal profiling, I mentioned using laser profilometer, it will give you the international roughness index, and transfer profile with the back lasers will give you the rut depth information. Now let us see the road profiling, the measurement of the longitudinal profile, its accuracy. The laser profilometer here, it is as per ASTM E950 class 1 category. What does it mean actually? Class 1 category means that you are generating the profile of the road at an interval of 25 millimeter interval. Okay, with the highest level of accuracy in the measurement. So we call it as a class 1 interval. If your measurement interval is more than 25 millimeter, that comes under class 2 category. So as per our IRC codes also, and the recommendations for the riding quality measurements, we go with class 1 category, and all lasers are capturing the longitudinal profile at interval of 25 millimeter. And finally, after calculating or after applying the appropriate algorithms, which is an automatic process, we get the international roughness index IRI in meter per kilometer. And if we want to convert this IRI equivalent to bump indicator roughness index, which is our old practice actually in India, so we can use this equation. We can put our IRI value here, and we can get the roughness index equivalent to the bump indicator values. So in that way, if you see this graph, we are getting three graphs here. One is the for the right wheel path, another one is the left wheel path, and the third one is the average of the both the wheel paths. Okay, so here I have one suggestion. Actually, most of the time I am seeing the data. So we are getting the data from all the suppliers, only the average IRI data. Why not we get both the wheel path data, left IRI and right wheel path? So this will not help you to see the riding quality on both the wheel path, but also you can compare. Okay, if you are at some time you are seeing the left wheel path and right wheel path of a newly constructed road, okay, you are getting much difference. That means this data is not correct. Okay, because if you are constructing a new road, as per our experience, we have collected so much data, there is no much difference, hardly a difference between the left wheel path and right wheel path. So in that way, you can also ensure, because sometimes maybe one sensor is not correctly measuring the profile of the road, but it is rarely that both sensors are not measuring the not properly measuring. Okay, in that way you can just compare the results of a, in case of newly constructed roads, I will mention left, what is the value of the left wheel path IRI, what is the value of the right wheel path IRI. If both are matching, that means your results are reliable. This is one way we do, and most of the time we found that that this is the appropriate way of having confidence on the measurement of the IRI data. And other thing which is very important here, because while collecting, because these laser sensors are continuously measuring the height from their position to the road surface. Okay, this is the principle actually how these laser sensors are collecting the information. Okay, because we have laser sensor, it is just sending one signal here to the road surface, and we are getting the reflected signal back. Okay, and it is measuring the height from its position. Okay, so in that way, and we have one accelerometer on the top of each laser sensor, which is measuring the acceleration, that is the body movement of the vehicle. Okay, and acceleration, we know in physics that if we are double integrating, we will get the vertical displacement. So we are just measuring the acceleration due to the body movement of the vehicle. The laser is measuring the height from its position to the road surface. And finally, we are double integrating this accelerometer value, and we are subtracting from the laser results to get the accurate road profile. Okay, but the one way to check whether your machine is giving you the correct riding quality or not is that you put it a known height block, okay, in between the laser and the road surface. Suppose you are putting a 25 millimeter block here, then your system will record 25 millimeter irregularity. You have put a block of 50 millimeter, the system will tell you 50 millimeter accuracy. But if you are putting a 25 millimeter block and your system is telling you this is 30 millimeter or it is 20 millimeter, that means your machine is not properly calibrated. Okay, so this is one check we do very occasionally, but many times I feel I see actually these network survey vehicle people are not demonstrating this at the time of measurement of the riding quality because they don't want to, I don't know, they don't want to share the calibration results. So this is one thing we should look into so that we can properly ensure that the machine is properly calibrated in respect of IRA. Because why I am saying IRA, because IRA is the most important parameter right now, for especially for the newly constructed roads, or if you want to do some maintenance planning for the existing roads. So this is the data actually we normally process the IRA data at 1 kilometer interval, and we get the IRA for right wheel path, we get the IRA for the left wheel path, and we get the average of the IRA. This is how, but if you want, this data can be, you can process at 100-meter interval also, 200-meter interval also. But as per the international practice, we for a network level or we do the processing at the interval of 1 kilometer. So these are some validation tools. Now, some people ask me how to validate whether this network survey vehicle has correctly measured the profile or not. So we have some instruments like walking profile is one, second is the dipstick is one, and Jet 250 and many more maybe. But we have worked with these instruments, and these instruments actually they are they give you the 100% true IRA values. I think my screen is not visible. Yeah. Okay. So in that way, if you want to cross check, okay, you want to validate the results from the network survey vehicle, you can use any one of these equipments for the comparison purpose. And these equipments basically are used for the calibration of the fifth wheel bump indicator right now. But you can use these equipments for the validation of the network survey vehicle IRA measurements, which how this is how we do validation of network survey vehicle at CRRI, right? And these are the guidelines. Now, if you want to go in more details of IRI or how to do calibration or using the these machines like the walking profiler or dipstick, and all these details are given in these guidelines on measurement of road roughness and norms. I will recommend to read this document published by ministry. Uh, um, and now let us see the road profiling in transverse directions. Again, this is a very important parameter, transverse profiling. Yeah, again, I'm. So still you can see my screen, sorry.
Yes, it's visible.
It's visible.
Yeah. So let us talk about the, now I think you have some idea about the longitudinal profile, the riding quality, IRI, left wheel path, right wheel path. Now let us see the transverse profiling. So how we are doing the transverse profiling. So in transverse profiling, I am seeing the three systems in the market. One system is this one, the first one. This is the first network survey vehicle in CRI, but some other people are also using the same technique because they want to generate the transverse profile. That means they want to make a profile of 3.5 meter lane. Okay. So in that way, what they have done, they have put 5 laser sensors. One here, one here, one here, one here, and one this one. So with these 5 points, they are creating a transverse profile, and they are trying to get the maximum point of depression along the wheel path so that they can come to know the rut depth values in millimeters. So I think this practice is very old, and we should not use this because the results which we are getting, they are not accurate until unless you have 13 plus laser point, okay, in this laser profilometer, which I think it is difficult also. But the second technology which we are using from the last 10 years, it is the which is called laser rut measurement system. Here we have two laser sensors which are emitting the laser waves, and in 3.5 meter we are generating the transverse profile for with 1280 points. So this number is very high, so that the transverse resolution between 2 points is less than 3 millimeter, and we are getting accurate results in respect of rut depth measurement. But more advanced system is now available, which we call 3D system sometimes, because in I will again let us wait actually when I will tell you the exact difference between 2D and 3D system. So in this system we are have the resolution is very high, more high in comparison to this system. So this is the latest technology, which sometimes we call LCMS, or some lidar based systems are also available in the market. So these people are giving a very dense data in transverse direction, so that your rut depth results are very good. So like this is the screen just to tell you what rut depth I am telling. Actually, we want the profile like this in transverse directions. This is my one wheel path and this is another wheel path, and we want to know the maximum point of depression along the wheel paths, which we call it the rut depth in millimeters. So this is very important parameter for us, and this is again the data which we collect: rut right data, rut left data, and rut average data. So this is the kilometer wise we process. Again, if you want, you can process it 100-meter wise if you are working on the project level. But for network level, it is recommended to process the data at kilometer wise. So again, if you want to validate these results, the only way is the 3-meter straight edge, the conventional method, which we use to measure the rut depth. This is the only way we can compare the results from the conventional method and with the network survey vehicle to know whether we are getting the accurate results or not. The third one is the road geometry measurement with network survey vehicle system. In road geometry, because we are going to use this geometry data in many ways in road safety audit related studies, and also in highway development and management tool HDM4 for life cycle cost analysis and the maintenance management system. So we want to know the gradient in percentage. We want to know the rise and fall in meter per kilometer, rise and fall number per kilometer, cross slope percentage, horizontal curvature degree and kilometer. The gyroscopes and accelerometers sensors are there fitted in network survey vehicle systems that measures the changes in orientation and acceleration of the survey vehicle. This is a very common hardware tools which are used to measure the geometry measurements, whether it is a 2D system or it is a 3D system. All the manufacturers are using the same type of sensors and for the measurement of the geometry data. So this is the important aspects. Actually, rise and fall we want to know in meter per kilometer using the network survey vehicle. So using the same geometry system, we want to know what are the number of rise and fall, rise and fall, because this information is very important when you are using the HDM4 tool. And again, we want to know the number of rise and fall per kilometer. So we want to know this information. But in some network survey vehicle providers, I am seeing that this information is missing. And in the absence of these parameters, it will be difficult for you to run HDM4. Your results will not be accurate. So we have to make sure that when we are collecting the data, it is useful actually in all aspects, whether you want to use it for the calculation of PCI, or you want to run HDM4 or some other management tools, so that there should not be any lack of information. Camber information we are getting using network survey vehicle, no issue. Horizontal curvature, again, we are getting with the network survey vehicle system. But again, this is the data like kilometer wise I have processed for the gradient, what is the camber, what is the curvature, latitude, longitude, and altitude information. So all these information we are automatically processing as per the desired interval. But again, the question here is the how we are validating it. So we have some mechanism to validate this geometry data also. The best way to validate is if you have some known gradients, you have known curvatures on your highways as per your drawing. So better you just first you compare with those results. Otherwise, the total station is the the last option for you. You can use that one, and you can validate your results. So this is how we are doing. The third one is the measurement of the payment surface distresses. Again, this is a very important part. If you want to collect the distress information, what is the cracking, what is the number of potholes. If you are doing this manually, it is not possible with the traffic, and it is a time consuming task for you. So this is the most important, and this is the only parameter which distinguish between 2D system and 3D system. If you want to measure IRI, so IRI measurement using laser profilometer is same in case of 2D system and 3D system. If you want to measure the geometry, it is same for both the systems. Okay. If you want to do the payment surface distress measurement, so here we have some change. Like in this case, first case, 2D system, you are seeing only two cameras facing downwards. So here you are capturing the images of the payment surfaces. That means you are not collecting the depth information of the pothole or crack. You are only getting the area. So what is the area? What area is cracked, or what is the area of the pothole? But if you are interested to know what is the width of the crack, or what is the depth of the crack, or what is the depth of my pothole, that means you want to quantify in terms of severity level also. So in that way, you have to go with the 3D system. But right now, I am not seeing any code where we are analyzing the data with respect to the severity level. We are just, we want to know what is the extent, that is the percentage, not the severity level. But I think if you are collecting the severity level information also, this will help us in future also to understood about the payment behavior and to revise the IRC guidelines, so that like international practices, we can rate our roads in terms of severity levels also. So this is a good thing if we have a 3D system in practice. But right now we are not utilizing this 3D information, that is the jet direction information or depth information we are not utilizing. So these are some images which we are collecting using the 2D system. You can see here, you can see the crack, some wide cracks you are seeing, some fine cracks you are seeing, and you are seeing the pothole. But this is a 2D system. But if you are using a 3D system, then that system will tell you the width of the crack also, or depth of the crack also, and the depth of the pothole also. So this is the difference between the 2D system and the 3D system. So this is another system I am seeing right now. This is the runway we are doing. We not only the highways or state roads, we are collecting the data using network survey vehicle, but recently I am working on a study with 10 airports. So we are evaluating the runways, taxiways, and apron area also using the network survey vehicle. So this is one image, recent image actually on the runways. These are the other images of the runways using the same technology which we are utilizing. This is the actually 3D system which we are using here, because we want to know the severity level also. So now the other dimension of network survey vehicle system, this is the important dimension. Again, people have some confusion about the like road asset camera. Okay, road asset camera, most of the time you will see in the front of the network survey vehicle, so that you can capture the roadside assets. Okay, you can just pinpoint the location, and you can just access the condition also. So here you are seeing the image captured by front camera of a network survey vehicle system. Okay, but the beauty of this image is that here whatever you are seeing, it is measurable in X and Y direction. If you want to know what is the lane width here, what is the lane width here, everything is measurable. So in that way, or if you want to know the location of this tree, or sometimes if you have properly calibrated, you want to know the height of this tree also, then it is also possible. So this is the beauty of this road asset camera. But now what I am seeing, uh, in my opinion, it depends how many cameras you are putting. Sometimes we are having only front camera because we are more interested in the carriageway details up to shoulder. Okay, but sometimes if you want to see the right of way information, you can put one left camera also, right camera also here. And but in my opinion, there is no need of back camera, or Now the new survey vehicle system, which we call 3D system, the people are collecting the 360-degree camera. The 360-degree camera they are using, and in this 360-degree camera we are getting the image of the sky also. I don't know why we have insisted to use a 360-degree camera when we are more interested to see the front, left, and right only. And I think if you have one camera in the front, that is this is the most desirable thing which we want to cover the entire carriageway. And then we want the sometimes we want to see in the left and the right, but I don't know, back and sky information is useful for anyone. But in the new systems I am seeing the cost is very high and people are using 360 camera. So this is one thing. And again, if you want to validate the results, it is very simple. You just measure it by tape and you just measure it by the system and you can compare the result. So here the validation part is very simple for all of us. Now another dimension is because all parameters, whether it is IRI or it is texture or it is geometry or it is the distances we want to know, we want to pinpoint the location in terms of the chainage, that is the distance, with reference to the kilometer stones or the geographical referencing system using global positioning system. We want to map the roads. So we recommend to use the real-time differential positioning system so that you will have accurate results in terms of longitude, latitude, and altitude. And if you are using the real-time differential GPS, which is the ultimate technology, so in that way, after creating the map, if you superimpose on the Google Earth, okay, so you will see your road alignment is perfectly matching on the Google map. Okay, but if you are using a simple GPS, then it will not match. So this is how the accuracy, you can enhance the accuracy for the location-based measurements using the real-time differential GPS. So we recommend to go with the global positioning system, which has the real-time differential capacity. Similarly, because all measurement, it depends. Suppose you are doing the IRI, okay, and if your distance measurement is not correct, then your IRI riding quality results will not be correct. So in that way, you need to have a very accurate distance measuring equipment. Sometimes what people are doing, they are just checking the laser profilometer, whether it is correctly measuring the height, 25 millimeter or 50 millimeter, but they forget to check the distance measurement with the network survey vehicle. Okay. So in that way, if you are not sure about the distance measurement, and if your system is measuring short distance or it is a more distance, then again, you are not getting the true IRI method. So again, we have to be very careful. So distance measurement, it is very easy to validate with the known distance. You can just validate the distance measured by the network survey system. So now let us see some the data like mapping events. We are suppose running the network survey vehicle on a particular roads, and we are just getting the so many features. We are pressing the keys. Actually, some bus stop is there, vehicle underpass is there. Sometimes we have pothole is there. So we have a key system, inbuilt key system. We can press the key, appropriate key, and the location of that event or the distress or any defect or any road inventory will be marked at that location. So we have that system like here, the bridge start point, end point. The blue line you are showing here, seeing here actually, this is the network survey vehicle, longitude, latitude, and altitude data. So this is the blue line, and we have superimposed this data to the Google Earth for the convenience. Like vehicle underpass, we have marked here. Bus stop, the operator has marked here. So bus stop is visible in the Google Earth also here. So in that way, you can do some, at the time of survey itself, you can do some inventorization and you can create the GIS layers of the different type of event. Like you want to create a layer for the culvert, you can just make a key for the culvert and you press that key, and the location of all culverts will be marked on the GIS map. But this work you can do it later on also at the time of processing the data in the lab itself also. So now I am showing you some typical network survey vehicle pictures. This is one picture. Again, this is the another view here. This is the 3D system. I think now you very clearly know what is the difference between 2D and 3D system. 2D system will not give you the depth information. That means it will not give you the severity levels. Okay. But if you are really interested to know what is the depth of my crack or what is the depth of my pothole, then you have to go with the 3D system. Otherwise, it is not going to affect. If 2D system, you will get the same results for IRI, texture, geometry, or right of way information. There is no difference between 2D and 3D, right? But so these are some systems like I'm just seeing in the market actually. So you can see here in this system, they have 360-degree camera in the top, and in the back side they have LCMS system. This is another technology I'm using on airports right now. This is lidar based systems. Again, they call it as a 3D system because they can give us the depth information. So this is a 3D system. So the thumb rule is that we are not going to check anybody, but if the system is able to give me the depth information of the porthole, that means it is a 3D system. Okay. So many systems of different shape and size are available in the market. But this is something very unique. I could see from the lidar based systems. Okay. If you really want to develop the digital twin of your road network. Now we are talking about the digital twin. We want to develop a virtual platform, okay, for our road network or our national highways. In that way, you have to go with some lidar based. We call it as a point cloud data. You have to collect for the entire roadway so that you can have the right way trees informative trees also or anything you are seeing you can digitize and all these things are measurable also. So this is how this was all about the network survey vehicle. I think I have covered all the aspects related to the measure parameters and how to ensure the accuracy in the measurements, all these things. So this was the network survey vehicle. And now how to use the data. So this is very important. So recently we have one new code. Actually, if you are collected the data using the network survey vehicle, so we have new code IRC 82 2023. So recently it was released by Honorable Minister in Raipur. So here we have let us just talk about the for highways only. We have some 6 parameters we have selected, okay, to rate a newly constructed road, or you can say the existing road for the maintenance planning purpose. So one parameter is the cracking, second one is the raveling, potholes, patching, rut depth, and IRI. So these are the most dominating parameters we could found on our highways. Okay. So we have the category also. Suppose my cracking level is less than 5%. I call it as excellent to good condition. That means 0 to 5%. Raveling is 0 to 1%. Pothole nil. Earlier it used to be 1 to 2. Actually, if you see the old code, okay. But now for highways, we want, if you want to say it is an excellent road or a new road, why it should be nil. Then similarly patching 0 to 1, rutting 0 to 5 mm, and IRI as per our IRC SP16 code. Okay, less than 2.55 IRI, which is you are getting from the laser profilometer, that means road is excellent to good. Okay, if it is up to 3.3 IRI level, that means it is satisfactory to fair, and then more than 3.3, it is 2400. So based on these boundary conditions, I call them as a boundary conditions for 6 parameters. We have developed the PCI models to convert these boundary conditions or the ratings into 0 to 100 scale, where 0 is the failed condition and 100 is the excellent condition of road. So we are just rating similarly in case of rural roads, and similarly for the urban roads, we have different boundary conditions and the PCI curves. So if you see finally, so these are the 6 parameters, and we have excellent to failed condition, where 100 is excellent and 0 is the failed condition. And based on the methodology developed in IRC 82-2023, it is given, we are calculating the PCI value of the each parameter, each PCI for IRI, PCI for pothole, PCI for a depth, PCI for cracking, PCI for leveling, and PCI for patchwork. And then finally, we are giving the weightages to each PCI value. Like IRI, we are giving the maximum weightage 0.4, and pothole we are giving the second highest 0.16, rut depth 0.14, cracking 0.12, raveling 0.10, and patchwork 0.08. Based on these weightages, finally we are getting a PCI score. Suppose my road is having a newly constructed road, I am getting a score more than 90 to 100. That means this road doesn't require any major maintenance. It requires only routine maintenance, like cleaning, drainage, cleaning, all these things. Suppose I am getting a score between 80 to 90, that it requires preventive maintenance, or here 40 to 60 minor rehabilitation, and then more than this major rehabilitation. Just a minute. Let me, I think, I don't know whether it is visible to you or not. Yeah. So poor more than 20 to 40 and 0 to 20, if you are getting, your road is getting a score based on the 6 parameter I have mentioned, that it requires reconstruction. So in that way, I am showing you, we have given one Excel utility table also, along with the this IRC code, that suppose your road is newly constructed, there is no cracking, zero cracking, raveling is again 0. Okay. Okay. Yeah. Pothole is 0, patching is 0, rut depth is 0, IRI is 2.5 meter per kilometer, which is very good. That means you are automatically getting score 100. This score you are getting automatically with the utility which we have given along with the code. And in that way, the system is suggesting you that only routine maintenance is required. Similarly, suppose you can see the 20 examples I am putting here in front of you. These are the real roads. Suppose in a road you are having 5% cracking, 2% traveling, 0 pothole, 3% patching, 4 rutting, IR is 6, then you are getting 52.77 score. And the system is suggesting you that minor rehabilitation is required. But for minor rehabilitation decision, if you just read the code, you have to go with the structural evaluation first, then the system will tell you exactly what minor rehabilitation or what type of overlay layer is required to restore it back to the good condition. So in that way, now you have something in your hand with the release of this document IRC 82-2023, that if you have collected the NSV data, you are getting cracking data from NSV, raveling data from NSV, pothole, patching, rut depth, IRE, all 6 parameter data you are getting from the NSV. So why not we put all this data into this utility and rate our roads and just find out what type of maintenance is required. So this is something. Yeah. So this is one very good initiative. Yeah. Just a minute. Yeah. ये ज़्यादा आगे क्या हो गया है इसको? This is not moving actually. I don't know. There is some glitch. Again, I have to share. Yeah. Yes. Yeah. So now another code we have published, like the guidelines road asset. One thing I forget actually. The models which we have developed, this is my research actually. I have just put my research. It is a SCI publication also. I have put my research into the, converted my research into the IRC 82 code. So this is how actually, and we have validated these results also as per the actual field conditions available with the real data. And this is the another code recently released, developed by the ministry, that is the road asset management system which we are talking. If you just go the chapter number 5, which was written by me, road asset data collection, it includes the all information related to the network survey vehicle. I am just giving you the glimpse of this document we have. If you want to develop a road asset management system, it has various modules related to traffic, payment, bridges, toll, accident, environment, and other documentation. Query system is there, and then how you are going to link with SDM4 so that you can do some life cycle cost analysis, or you can do some economic based analysis optimize the economic benefits in terms of minimizing the maintenance cost and road user cost. So all these things are there, and in this document we are just giving you details of the data requirements for the RAMs. The static data is required, which you can collect from the records, and dynamic data you can collect from the network survey vehicle and some other means like falling weight deflectometer or traffic countercome classifiers or weigh in motion system or GPR technology is there. And there are some guidelines also we are giving that we should not collect the excessive data. We should just concentrate how we are going to analyze the data so that we can minimize the efforts in data collection and we can make it more sustainable, the data collection activity. All these things are there, and we have also given the frequency of the data collections. So based on our experience, the most appropriate time for data collection is the after monsoon actually. So if you are collecting the condition data, functional data every year, so you should collect after monsoon, okay? Or road inventory you can collect after 5 years, or structural data 3 to 5 years, or payment functional data every year, payment surface condition every year, and traffic data every year. So this is all information is given. If you read this chapter, you will have answer of all of your queries. If you want to select the appropriate technology for the roughness measurement or distresses or friction, or how to measure the crust details, from where to get the cost details, or policy related, geometry related, or if I am having a 4-lane divided carriageway, what technology shall I use? Or if I am having 2-lane road undivided or single lane road, what method shall I adopt? All these things are there in this document. So this is, you can just go through it. And also in this document we have given some special features of automated road service system or network survey vehicle, laser profilometer, what is the speed range and everything, it is there. And the SDM4 software, just I'm giving you very quick details, like that all data, network survey vehicle data, first you can use using IRC82 document to rate the roads, to know the tentative maintenance strategies. But if you want to do the economic analysis, then you have to go with the highway development and management tool. This is the World Bank has developed this tool, and most of the time for the state level where the funding is from the World Bank, we are using this tool to develop the annual maintenance plans. So actually the idea here is to minimize the total transportation cost and maximize benefits within the budget constraints. So this is the thing which we are doing using this code. And these are some studies. I mentioned that the first study was initiated by Ministry of Road Transport and Highways in 2006 and completed in 2010. We have developed this GIS-based National Highway Information System, first one with 40,000 kilometers of national highway data using network survey vehicle system. Then the second one was the Golden Quadrilateral, you can say the high-speed road corridors we have done. And then now continuously from the 2012, we are working with Odisha government for the entire state. Actually, we are covering state highways, MDR and ODR roads, and we are developing, working with them for Odisha Road Asset Management System. Presently, also we are working with them. Recently, we have completed the 21,000 lane kilometer data collection using network survey vehicle in the last month itself. And now we are developing the annual maintenance plan. In the year 2022, we have developed the Kerala Road Maintenance Management System using with the help of network survey vehicle, falling weight deflectometer, and the other source of data. And the SDM4 software, we have successfully delivered this project to them. And also, I am leading as a project leader for the 10 airports of the India. We are developing airfield payment management system for the 10 airports. Again, here also we are utilizing the network survey vehicle system for the condition monitoring of the runways, especially, and as per the ACAO guidelines, International Civil Aviation Organization guidelines. So these some sites are very important. Now I have some recommendations for the network survey vehicle service providers. One is the calibration and maintenance is required. They are doing calibration, they are doing maintenance, but they are not keeping the records, because whenever we ask them, they are not able to show us when was the last calibration was done and what were the results actually. So we don't have, there must be some quality assurance procedures at the site site itself. If I want to just ensure whether the machine is properly calibrated, there must be some site checks also. So this always I recommend. Real-time monitoring system must be there to ensure that all the sensors are working again at the site. GPS, as I mentioned, that we want to have this real-time differential GPS so that we are getting the at least centimeter level accuracy. And environmental conditions, they should take care of the environmental conditions at the time of data collection so that the good lighting conditions are available at the time of data collection, and it should not be a rainy day. It is going to badly affect the data accuracy in data measurement. Training and skill development, most of the time I never see the you can say some training certificate of the operators. So this is missing. The NSV service provider must ensure that the person they are deploying for the data collection is properly well trained in data collections, and he's taking care of sometimes the results are not proper, then he must be able to address all those things at the time of data collection itself. Documentation and reporting is again very important. It is not just to collect the NSV data, but there must be some validation checks, data validation checks methodology, and we should finally analyze at least as per IRC 82 guidelines to get the PCI rating and the maintenance strategies. So these are some survey recommendations. Again, the calibration check, ground truth verification is very much required. We do in Odisha actually ground truth verifications for some sample roads, and quality control checks we are also doing. And there must be some consistent speed also. It should not be like this technology is good for 20 to 100 kilometer per hour, but as per our experience, if you are maintaining some for national highways, suppose you are collecting the data at 50 or 60 kilometer per hour, then you will get a good results. And weather considerations are very important. That is the a adverse weather such as rain or poor lighting condition can affect sensor performance and data quality. So all these things are some recommendations, and there are some other recommendations for data analysis. We must analyze, at least we should utilize the NSV data for rating of roads on PCI scale as per IRC 82 should be made mandatory once you are collecting the NSV data, because all 6 parameters you are getting from the NSV, so there should not be any problem to rate the roads as per PCI scale. And then further, as per the requirement, we can go for the strategy level analysis or program level analysis or project level analysis using the HDM for softwares, which we are presently doing. We have completed in Kerala and presently doing in Odisha state. So like that we can do, and these are some national guidelines. Everyone should read these guidelines. These guidelines are related to NSV also, road maintenance basically. So maintenance, these are all new guidelines if you see. So these are something which we have, and I have written 2 books also related to, you can say, the data collection manual on payment evaluation techniques is very good book, and here you can have one chapter on network survey vehicle validation techniques also. But this book is something different. Actually, this book I have written with the Professor Satish Chandra. He's the professor IIT Roorkee, and this book I have written with Professor Manoranjan Parida, who is the present director of CRI. But this book is something related to the research people, not for the field practitioners. So I will recommend the first book if you are interested to go in more details. And we have continuous regular training programs on road maintenance aspects, and these are the coming programs at CRI. First one is in the month of September on payment evaluation techniques and their application for maintenance and rehabilitation, and the second one is the on road asset management. This includes the training on SDM4 also. This will be on 14th to 19th October for 6 days. But other than this, if you want for NHAI or some other, especially for NHAI, we can have some customized training program as per your and our convenience anytime. So
Certainly.
here's something. And thank you very much for your kind attention. Sorry, I think I have taken some.
Thank you, Dr. Saab, for a very, very insightful and very, that is
डॉक्टर प्रदीप
all fundamentals.
डॉक्टर प्रदीप बहुत बहुत धन्यवाद. मतलब टू ए नोविस लाइक मी
Yes, sir.
I could get the nuances of it. Yeah, I'm sure जो पूरी हमारी field की team है सबको it has enlightened a lot. और पाड़ी
सर
at the end of presentation डॉक्टर प्रदीप का नंबर वगैरह शेयर करो ताकि in case
Sure.
किस फील्ड में किसी कुछ अगर कोई होता है तो my request is he should if Dr. Pradeep is kind enough number mobile अगर कोई query कभी बाद में फ्यूचर में किसी को आता है they can directly contact him.
जी,
Sir,
sir.
we will sir, anybody has any queries, we will give that एक नोडल ऑफिसर हमारा मिस्टर अमित मुंजाल उनका ईमेल कर दीजिएगा, ईमेल एड्रेस विल शेयर शॉर्टली। उस बेसिस में हम कोलेक्ट करके वी विल टेक व्यूज फ्रॉम दिस प्रदीप कुमार साहब से हम पूरा रिप्लाई ले लेंगे सर, सो दैट इट विल गिव ए स्ट्रक्चर्ड वे में उसका रिप्लाई हम बनवा के वी विल शेयर अगेन विद द पार्टिसिपेंट सर।
Right, Paddy, move. Yeah.
थैंक यू सर, थैंक यू सर। फ्रेंड्स उसका अभी जैसे साहब का प्रदीप कुमार साहब का जैसे एनएसपी का टेक्नोलॉजी के ऊपर बात किया है, उस टेक्नोलॉजी को लिवरेज करते हुए एनएचआई क्या कर रहा है, हमारा कैसे मेंटेनेंस मॉड्यूल है, और हम 3D टेक्नोलॉजी को जैसे साहब कह रहे थे 3D टेक्नोलॉजी, उसका ऊपर भी हम 50,000 किलोमीटर का ऑलरेडी ये बुला चुका है, अवार्ड कर चुके हैं। 1 मई से ये 50,000 किलोमीटर में हमारा 3D टेक्नोलॉजी के साथ में एनएसबी का डाटा कलेक्शन होगा, और उसका डाटा कलेक्शन को जैसे आज का डेट में बहुत महीनों लग जाता है, उसको हम बिल्कुल कंस्ट्रेंड वे में विद इन 10 डेज उस डाटा का एवोल्यूशन करेंगे, सेंट्रलाइज्ड एवोल्यूशन करेंगे, हेडक्वार्टर में एवोल्यूशन करेंगे, उसको डाटा लेक में डालेंगे, और उसको कैसे ओएंडम के साथ में मिंगलिंग करते हुए एनफोर्स करने के लिए आपको पूरा के पूरा डॉक्यूमेंट भी तैयार करके देंगे। अभी मैं रिक्वेस्ट करूंगा अमित, आप इसका बड़ा क्विकली 10 मिनट अपना क्या क्या करने वाला है जरा बता देना।
ओके सर, थैंक यू सर।
थोड़ा क्विक 10 मिनट में कर दो क्योंकि अभी काफी टाइम हो गया,
यस सर,
लंच का टाइम भी हो जाएगा। थैंक यू, गो अहेड।
यस सर, मैं स्क्रीन शेयर करता हूँ। सर मेरा सर स्क्रीन विजिबल है सर?
Yes.
Okay, sir. Good morning, everyone. My name is Amit Munjal, working as DGM in Highway Operations Unit, NHAI headquarters. The topic allocated to me today for today's discussion is related to the NSV adoption in NHAI, the challenges we have faced, and the way forward. So the general objective of every activity we do is to provide better roads to the citizens of the country. And there is one initiative in this direction, which is creation of road asset management system. In short, we call it as RAMS. It has been created by the ministry and NHAI together. The broad objective of RAMS is to create a database which includes road inventory data as well as the condition of the pavements and the overall road. And this data should be used for the planning as well as budgeting purpose. As Dr. Pradeep has also given detailed information on the RAMS, so I will not discuss much about RAMS. I will just talk about the broad objectives of RAM is to create the database which include this road inventory and the condition of road. There is one interesting output which our existing RAM system is able to give, which you can see in this picture also. It's a color coded map of road condition. The different colors of this road shows the different condition level of the road. For example, based on the cracks or roughness, it is showing. Because this data is huge, what we collect through NSV, there are lakhs of entries. This tool of presenting it in a color-coded way is very helpful. It is very easy to understand and we can take quick decisions. So we have also kept this new output in our the new NSV tender. I will discuss that in the later part of the presentation. So anyways, the task of uploading data on the RAMs for all national highways have been entrusted to NHAI from the starting itself. So whether it's a road of PWD or NHAI DCL, we are the responsible authority for getting this data from different agencies and uploading it on the RAMS portal. For this purpose, we have a dedicated teams in NHAI headquarters called RAMS cell. Their duty is to validate the data received from the field units before uploading the same into the RAMS portal. So because our objective is we should not upload the inaccurate data in the RAMS portal. So this slide shows our existing arrangement of the data collection, validation, and uploading exercise. There are many stakeholders in this system. First is our executing agencies like NHAI, NHIDCL, or PWDs or BRO. Their duty is to collect the field data, prepare the final report in the already circulated template, also available on the website also, and upload it in the data lake portal. The obligation of our data lake portal, that is which is managed by Messrs. MNEX, is just to transport the data from the field to our NHAI headquarters. They are not into the validation of this data. The validation of data is done by the RAM cell at NHAI headquarters, which examine the data for its completeness as per the template, the accuracy as per the video submitted. If the data is in the accurate acceptable form, the data is uploaded in RAMS portal. Otherwise, it is returned back to the field unit for correction. This RAMS portal is a separate portal being managed, handled by the ministry through their agency called Messrs. DXC. So these four are overall stakeholders in this system. Now we know the utility of NSV testing is huge, as sir has also mentioned. It's a great potential. NSV testing, it can collect and analyze a lot of data which is manually or any other way it's not possible for us. So this has been realized by the decision makers also. So therefore ministry in 2019 made it mandatory to conduct NSV survey at 3 stages. First is before the start of work. Second is at the time of completion, that is before issue of PCC, we have to mandatorily conduct NSV. And after completion, every 6 months, NSV test have to be done. It is also being followed throughout our national highways. However, we face some challenges during implementation of this NSV data collection and uploading. One slide has been kept for these, showing these challenges. The main challenge we have faced in the RAMS data uploading is that we are not getting the complete data of an entire NH network.
एक सेकंड, आई वांट टू एक्सप्लेन दिस. जैसे हम लोगों को पता है हर 6 महीना में हमने हर जगह में डाटा एनएसबी का डाटा हमको कलेक्शन करना है और उस डाटा को हम फिर राम सेल में उसको वैलिडेट करने के बाद उसको यूसेज करना है. हमारे पास 3 चैलेंजेस है. एक तो जहाँ पे डाटा कलेक्शन करना है वहाँ डाटा कलेक्शन नहीं हो रहा है. जैसे आप देखेंगे 37,000 किलोमीटर में हमको 2023 में डाटा कलेक्शन था. एक 27,000 है, एक 28,000 है. मतलब यहाँ पे भी हमारा कम से मतलब 30% डाटा अभी आज का डेट में भी कलेक्शन नहीं हो रहा है. उसके बाद जो डाटा आता है उस डाटा का टाइमिंग इतना, मतलब आप डाटा का एक्यूरेसी इतना खराब है. राम सेल में उतने बहुत सारे उसका डाउट्स और उसको ऊपर में क्वेरीज आता है. उस क्वेरीज को करेक्शन करते करते इसका इतना टाइम लग जाता है. ये वैलिडेट होता है, कभी कभी क्या होता है अगला साइकिल आ जाता है. सो उसका मतलब क्या होता है, मोस्ट ऑफ द केसेस इट लूजेस इट रिलेवेंस. मतलब इसका जिस पर्पस के लिए हम डाटा को यूज करना था, जिस पर्पस के लिए उस डाटा से हम जो लिवरेज करने का सोच रहे थे, वो सब खत्म हो जाता है. अब ये देखेंगे बहुत ज्यादा मतलब पीछे पड़ने के बाद, मतलब एकदम चेयरमैन सर भी कई बार इसका पीछे मीटिंग किए, इतने बार करने के बाद आज भी देखिए 37,000 किलोमीटर में 27,000 किलोमीटर डाटा आया. तो इसी चीज को देखते हुए हमारा रिक्वेस्ट रहेगा कि फील्ड ऑफिस में ये जो डाटा है इसको कलेक्शन करवाना ही करवाना है. एई का थ्रू हो या आई का थ्रू हो या आपके पास एनएसबी का ऑलरेडी हमारा एम्पानल्ड एजेंसी से उसके ऊपर करना. नेक्स्ट दिखा देना एक बार.
यस
नेक्स्ट प्लीज.
यस.
तो ये जैसे हम बता रहे थे कैसे आप कर रहे थे. अब इसमें जैसे जो अभी जो प्रेजेंटली 2D डाटा में कलेक्शन कर रहे थे, जैसे प्रदीप कुमार सर भी बता रहे थे, 2D में हमारे लिमिटेशन है. जैसे क्रैक्स है, वो क्रैक्स का ना डेप्थ बताएगा ना विड्थ बताएगा. हमारा जो शेड्यूल्स है, शेड्यूल के है बीओटी और हैम में, शेड्यूल एफ है टीओटी में, शेड्यूल ई है, शेड्यूल एम है, मतलब जहाँ पे हमारा O&M का कोविनेंट्स डिसाइडेड है, डिफाइंड है, वहां पे इंटरवेंशन लेवल डिफाइंड है, उस डाटा को हमको एनफोर्स करना है, तो वहां पे क्रैक भी बहुत इंपॉर्टेंट कैटेगरी है। और वो सब चीज में क्या होता है, प्रेजेंट 2D डाटा में वो लिमिटेशंस है, इसलिए मतलब विद द मैनेजमेंट डायरेक्शन हमने 3D टेक्नोलॉजी के साथ हमने फॉरवर्ड कर लिए है। एंड आई एम एक्चुअली वेरी हैप्पी टू इन्फॉर्म यू दैट 50,000 किलोमीटर का हमने 1 लाख किलोमीटर आइडेंटिफाई किया है, उसमें 50,000 किलोमीटर का जहां पे O&M स्टेज में है, उसके लिए ऑलरेडी हमने दिल्ली, नॉट पार्ट ऑफ द कंट्री, दिल्ली, हरियाणा, पंजाब, हिमाचल, जम्मू कश्मीर, राजस्थान, गुजरात, महाराष्ट्र एंड मध्य प्रदेश, इसी सारे स्टेज में अराउंड 50,000 किलोमीटर का 3D टेक्नोलॉजी के साथ अपने अवार्ड कर दिया है। और ये मई फर्स्ट वीक में इसका शुरू हो जाएगा। अब इसका कैसे करना है, नेक्स्ट करना,
Yes.
इसको टाइम बाउंड मैनर में करना है, क्योंकि जो पुराना में खामियां क्या था, डाटा कलेक्शन में बहुत खामियां होता था। अब हम क्या करेंगे, डाटा कलेक्शन जो करेगा, जो डाटा आज कलेक्ट करेगा, इट मस्ट रीच विद इन ए डे, अगला दिन ये क्लाउड का बेसिस में या स्पेशल कोरियर के साथ ये डाटा हमारा हेडक्वार्टर में पहुंचेगा NSP सेल में। उसमें साथ 4 दिन में, 4 दिन के अंदर में उसको डाटा का एक्सट्रैक्शन करेंगे, प्रोसेसिंग, प्रिपरेशन और रिपोर्ट तैयार कर देंगे, जो 8 दिन में, जो आज 6 महीने लग रहा है, आज का डेट में 6 महीने के बाद जो एक्यूरेटली नहीं हो रहा है, उसको हम 8 दिन में करने का हमारा एंडेवर है। उसके बाद 1 दिन में उसको रिजल्ट को रिव्यू करेगा एजेंसी, जिस एजेंसी ने काम करेगा, उसके बाद वो डाटा 10वीं दिन NHI को सबमिट कर देगा, जो वैलिडेटेड डाटा है। उस डाटा को वैलिडेट करते हुए हम इमीडिएटली उसको डाटा लेक में डाल देंगे। और डाटा लेक में जो प्रायोरिटी मेंटेनेंस मॉड्यूल है आज का डेट में, जिसमें 4 एट्रीब्यूट आज का डेट में हम कोशिश कर रहे हैं लेने के लिए, रफनेस, रटिंग, पोर्टोल और क्रैक्स, ये चारों की चारों बिग एक्यूरेट के डाटा के साथ आ जाएगा। और इस डाटा के साथ हम प्रायोरिटी मेंटेनेंस मॉड्यूल के साथ इसको लिवरेज कर देंगे, लिंकिंग कर देंगे। और वो प्रायोरिटी मेंटेनेंस मॉड्यूल में ये जो डाटा आएगा, उसमें ऑलरेडी हर एक कॉन्ट्रैक्ट का शेड्यूल के हिसाब से उसका क्या क्या रिक्वायरमेंट है वो भरा हुआ है। मतलब उसमें बताया हुआ है फोटोल का कितने दिन में करना है, रटिंग के लिए आपका क्या कितना रटिंग तक अलाउड है और कितना परसेंटेज हो सकता है, क्रैक का कितना विड्थ, कितना डेप्थ, कितना परसेंटेज है वो अलाउबल है, उसके ऊपर हो जाएगा। या आपका रफनेस का कहीं 2400 है, कहीं 2750 है, कहीं 2000 है, वो डाटा ऑलरेडी प्री फिल्ड डाटा है, हर यूपीसी कोड के साथ किया हुआ है। उस डाटा का फिल करने के बाद ऑटोमेटिक मॉडल में आपका प्रायोरिटी मेंटेनेंस मॉडल में आ जाएगा कि ये 4 एट्रीब्यूट में आपके प्रोजेक्ट में कहाँ कमियां हैं। और उस डाटा के साथ में हम लोग, आपका मॉड्यूल तैयार हो जाएगा। हम और भी वर्कआउट ये कर रहे हैं कि ऑटोमेटिक उसका ऊपर में जो भी इंजीनियर है उससे एक लेटर में ऑटोमेटिक एक ऑटो फिल्ड लेटर तैयार हो जाएगा। उस लेटर को अथॉरिटी इंजीनियर को या इंडिपेंडेंट इंजीनियर को सिर्फ भेजना है, कॉन्ट्रैक्टर को, कंसेशनर को बताना है कि आपका यहाँ पे रफनेस ज्यादा है, यहाँ से यहाँ पे आपका राइटिंग ज्यादा है या पोर्टल से, और इसका कॉन्ट्रैक्चुअल रिक्वायरमेंट इतना है, इतने दिन के अंदर इसको आपको काम करना है। उसके बाद उसी दिन तक जो काम करना शुरू करेगा उसका फोटो आएगा। उसके बाद पीडी का काम शुरू होता है, वेरी वेरी इंपॉर्टेंट पीडी। और एई का काम यह है कि एई लेटर लिख दिया और पीडी को ग्राउंड में चेक करना है कि वो काम शुरू किया कि नहीं किया है, क्योंकि उसका जो टाइमलाइन है उस टाइमलाइन के अंदर वो प्रोग्रेस ठीक हो रहा है नहीं हो रहा है। कभी कभी पीडी को हमने उसमें पावर भी दिया हुआ है कि उसको लगता है पीडी को कि बिकॉज ऑफ सम रीजंस व्हिच इज नॉट एट्रीब्यूटेबल बोथ पार्टीज, उसमें थोड़ा टाइम मिलेगा, वो एक्सटेंशन भी दे सकता है। नहीं होगा तो ही विल इमीडिएटली थ्रू द डाटा ओनली इमीडिएटली जीएम हेडक्वार्टर को भेज देगा कि जीएम हेडक्वार्टर को बताएगा कि यहाँ पे कॉन्ट्रैक्टर कंसेशनर ये जो शेड्यूल के हिसाब से मेंटेनेंस को नहीं कर रहे और आप उनको नोटिस दीजिए, और नोटिस के साथ साथ आप रिस्क एंड कॉस्ट में काम करना है। ये सारे हम डाटा को करने का कोशिश कर रहे हैं, क्योंकि इसके बाद क्या होगा, आप लोग मतलब ये सोच के चलिए कि 100% काम जो O&M का एक्टिविटी, जो कंसेशनर का एक्टिविटी है, जो करना है, एनफोर्स नहीं कर पा रहे हैं विदाउट स्पेंडिंग एनी एक्सपेंडिचर, कोई पैसा खर्चा नहीं करना है, एनफोर्स करके हम इस काम को कर देंगे, या कॉन्ट्रैक्चर का रिस्क एंड कॉस्ट में इस काम को करके उससे हम माइनस करवा देंगे एस्क्रो अकाउंट में। इसके साथ साथ ये डाटा कॉन्ट्रैक्टर के लिए भी फायदा है, कंसेशनर के लिए फायदा है, क्योंकि ये डाटा इनको पहले से बताएगा कि यहाँ इतना क्रैक्स है, ये क्रैक आगे जाके पोर्टल में डेवलप होगा, ये रटिंग होने का स्कोप है, या रेवलिंग हो रहा है, और यहाँ पे रफनेस बढ़ रहा है। तो ये सारा डाटा उनके लिए भी मेंटेनेंस, जो लॉन्ग टर्म मेंटेनेंस के लिए यूज आएगा। ये डाटा मतलब इट इज विन विन सिचुएशन फॉर एवरीबॉडी। बट अनफॉर्चुनेटली जो जितने भी साइट में है, ना हमारा स्टाफ, ना हमारा प्रोजेक्ट डायरेक्टर्स, ना ऑफिसर्स इसके बारे में ज्यादा ध्यान दे रहे हैं। अब मेरा रिक्वेस्ट ये रहेगा, प्रायोरिटी मेंटेनेंस मॉडल के ऊपर ध्यान देंगे तो एक तो मेंटेनेंस ठीक हो जाएगा, दूसरा कम खर्चे में होगा, तीसरा ये यूजर के लिए एक बहुत बड़ा हमारा जो ऑब्लिगेशन है उसको हम फुलफिल कर पाएंगे। तो हमारा ये कहना है, जो इसका जो वे फॉरवर्ड यही है, मैंडेटरी बाय एनएसपी को टाइमली कीजिए। हम जो अभी 3D में कर रहे हैं वो करेंगे, या 2D का जो चल रहा है उसको करिए, डाटा लेक में भर के भेजिए, और रामसेल का जो भी डाटा का रिक्वायरमेंट है पुराना मॉडल में जो भी आ रहा है उसको इमीडिएटली आप उसका क्वेरी को क्लैरिफाई करिए, और प्रायोरिटी मेंटेनेंस मॉडल को एक्टिव करते हुए उस कॉन्ट्रैक्टर का, बिकॉज ए और आई में O&M स्टेज में बहुत काम नहीं होता है, इनको उसमें यूज थोड़ा सा यूजफुल करना शुरू कर देंगे, उस डाटा को लेते हुए आप कॉन्ट्रैक्चुअली इतना बढ़िया एनफोर्स कर सकते हैं, इतना बढ़िया से आपको प्रिवेंटिव एक्शन ले सकते हैं, ताकि उसमें बिना एक्सपेंडिचर दोनों के लिए फायदा होगा, कॉन्ट्रैक्टर के फायदा होगा, यूजर के लिए भी फायदा होगा। और ये चीज को लेते हुए SLA को हम बना रहे हैं, तो हमारा रिक्वेस्ट ये रहेगा, थोड़ा सा आपको ये मेंटेनेंस मॉड्यूल के ऊपर में ध्यान देने का रिक्वेस्ट है। थैंक यू।
सर एक लास्ट स्लाइड वो फ्लाई ऐश
बता दो। एक सर चेयरमैन सर ने हमको एक बात हुआ था कि ये जो फ्लाई ऐश का इज ए डिफरेंट टॉपिक, लेट अस क्लोज दैट NSP वाला रिलेटेड O&M वाला टॉपिक नहीं है, बट ये एक बड़ा पेटिनेंट टॉपिक है कि ये हमेशा ये डिस्कशन आ रहा है कि जो फ्लाई ऐश का रिक्वायरमेंट है 31 दिसंबर 2021 के बाद जो MOEF का गाइडलाइन चेंज हो गया और जो नोटिफिकेशन चेंज हुआ, उसमें फ्लाई ऐश को का वेरी में NHA का क्या रिस्पॉन्सिबिलिटी है, कॉन्ट्रैक्टर का क्या रिस्पॉन्सिबिलिटी है, हमारा ऑब्लिगेशन क्या है, इसमें थोड़ा कंफ्यूजन है। जैसे अभी तक हम लोग 25 जनवरी 2016 और 31 दिसंबर 2021 के बीच में जितना भी बिड आया था, उसमें एक कंपलसरी था कि 300 किलोमीटर के अंदर में जो भी फ्लाई ऐश अवेलेबल है NTPC का या दूसरा थर्मल पावर प्लांट, लिग्नाइट बेस्ड थर्मल पावर प्लांट का फ्लाई ऐश अवेलेबल है, उस फ्लाई ऐश को मैंडेटरली यूज करने का प्रोविजन था। और उसके साथ साथ दूसरा ऑब्लिगेशन टू दी थर्मल पावर प्लांट्स को था कि उसका ट्रांसपोर्टेशन कॉस्ट वो बियर करे, और साइट तक जो भी ट्रांसपोर्टेशन कॉस्ट आएगा उसको बियर करने का बात था। यहाँ इसके लिए बहुत सारे मशक्कत किया गया, मतलब चेयरमैन साहब ने कई मीटिंग किए थे, और फाइनली पावर मिनिस्ट्री से हमने एक्सेप्ट करके जून 2023 में एक बड़ा सर्कुलर क्लियर निकाल दिया था कि किस टाइप का करना है, हम कैसे इंसिस्ट करना है, कैसे फैसिलिटेट करना है, फ्लाई ऐश को कैसे मंगवाना है, और उसका कॉस्ट बियर करने के लिए उसको कैसे इंसिस्ट करना है, वो उसका अंदर काफी हमने सर्कुलर दिया हुआ है। एक जुलाई में भी 13 जुलाई को एक सर्कुलर दिया हुआ है कि उसका पेमेंट भी कैसे करना है, उसका मॉनिटरिंग कैसे करना है, मेजरमेंट भी कैसे करना है, 13 जुलाई 2023 को एक सर्कुलर दिया हुआ। अब जो मुद्दा आज का मुद्दा है जिसका अंदर में कंफ्यूजन ही आ रहा है, 31 दिसंबर 2021 के बाद में जो MOEF का गाइडलाइन में चेंज हुआ है, जो नोटिफिकेशन लॉ ऑफ द लैंड MOEF गाइडलाइंस, MOEF का नोटिफिकेशन इज लॉ ऑफ द लैंड है, उसने क्या हुआ है, द कंपल्सन टू यूज फ्लाई ऐश विद इन 300 किलोमीटर्स आप सिचुएशन ऑफ TPP अभी वो खत्म हो गया। इसका मतलब ये है कि कोई भी रोड प्रोजेक्ट में 300 किलोमीटर के अंदर TPP थर्मल पावर प्लांट्स है तो उसका फ्लाई ऐश यूज करना कंपलसरी आज का डेट में नहीं है। कंपलसरी सिर्फ 2 कंडीशन में होगा, जब भी होगा कि इफ इट इज डिलीवर्ड एट द प्रोजेक्ट साइट फ्री ऑफ कॉस्ट एंड ट्रांसपोर्टेशन कॉस्ट इज बोर्न बाय कोल/लिग्नाइट बेस्ड थर्मल पावर प्लांट्स। इसका मतलब हमारे लिए कंपल्सन तब भी आएगा जब ट्रांसपोर्टेशन कॉस्ट बियर करने का मतलब उसके साथ कंडीशन के साथ थर्मल पावर प्लांट्स अपना एजेंसीज को आके बोलेंगे कि हम उनको एक नोटिस सर्व करेंगे कि मैं आपको ट्रांसपोर्टेशन कॉस्ट बियर करते हुए फ्लाई ऐश आपका वर्क साइट पे प्रोवाइड करूंगा, वो नोटिस सर्व करेगा, तब हमारे लिए कंपलसरी होगा उस फ्लाई ऐश को यूज करने के लिए। इसका 3rd पैराग्राफ पढ़ लीजिए, provided further that thermal power plant may charge for as cost or transportation as per mutually agreed terms in case thermal power plant is able to dispose as through other means, and those agencies make a request for it, and provisions for as free cost and free transportation will applicable if thermal plant serves a notice and construction agency for the same। इसका मतलब क्या है कि 31 दिसंबर 2021 के बाद जो भी बिड्स आया है उसमें NHA का ऑब्लिगेशन थर्मल पावर प्लांट से फ्लाई ऐश को फैसिलिटेट करना नहीं है। इट इज लाइक सम अदर थिंग, ठीक है, लेकिन उसका फ्री ऑफ कॉस्ट में देना है नहीं देना है, ये कॉन्ट्रैक्ट का और TPP प्लांट का ऊपर में दोनों का म्यूचुअल अंडरस्टैंडिंग है। कंट्रैक्टर उससे फ्री ऑफ कॉस्ट भी ले सकता है, खरीद के भी ले सकता है। हाँ, उसके लिए हम उसको फ्लायर्स यूज करने के लिए कंपल्सन नहीं दे सकते। लेकिन थर्मल पावर प्लांट नोटिस सर्व करेगा, कॉन्ट्रैक्टर को बोलेगा कि हम कॉस्ट बियर करेंगे और फ्लायर्स आपको सप्लाई करेंगे, तब द कॉन्ट्रैक्टर विल बी अंडर ऑब्लिगेशन, अंडर लॉफुल ऑब्लिगेशन टू यूज फ्लायर्स। तो इसके लिए जो हमारा जो डिस्कशन में बात ये आ रहा है कि एनएचआई को इसके अंदर में बहुत ज्यादा ऑब्लिगेशन पॉइंट ऑफ व्यू में नहीं करना है। फैसिलिटेशन के लिए कॉस्ट बेयर करने के लिए चिट्ठी लिखने का जरूरत नहीं है। ये कॉन्ट्रैक्टर का और उनका मुद्दा है, क्योंकि कॉन्ट्रैक्टर को ये जो नोटिफिकेशन है ड्यूरिंग बिडिंग टाइम उसको पता है। तो ड्यूरिंग बिडिंग टाइम ये अपना बिड में ये चीज दिया होगा कि वो फ्लायर्स यूज करेगा या नहीं करेगा। करेगा तो क्या कॉस्ट दे के खरीदेगा, या फ्लायर्स फ्री में लेके ट्रांसपोर्टेशन बियर करेगा, या उसके पास इतना कंपेटेंट उसका वो मतलब वो है कि फ्लायर्स उसको सप्लाई फ्री ऑफ कॉस्ट टीपीपीस करेंगे। ये चीजें को अपने बिड में उसने किया होगा। तो इसलिए ये कॉन्ट्रैक्टर का और टीपीपी का मुद्दा है। हम फैसिलिटेट कर सकते हैं फॉर दी सप्लाई प्रोजेक्ट प्रोग्रेस के लिए, बट कॉस्ट बियरिंग के एक्सपेक्ट के ऊपर हम लोगों को इसके ऊपर या मैंडेटरी यूसेज के लिए हम कॉन्ट्रैक्टर के साथ या टीपीपी के साथ कम्युनिकेशन नहीं करना। ये हमारा इन प्रिंसिपल बात है।